Assalamualaikum and good day. So today I would like to share with you topics 2.6 Parametric Differentiation. Okay, at the end of this video, students should be able to differentiate a function defined parametrically and find the second derivative of such a function. However, this objective will be discussed in the next topics. Okay, what is actually parametric equation? Instead of a function y(x) being defined explicitly in terms of the independent variable x, it is sometimes useful to define both function or x and y in terms of a third variable t, and we call this as parameter. Okay, so for example of parametric equation, let's say we have y equal to sine t and x equal to cos t. And then we can find derivative of y with respect to x based on these two parametric equation. Okay, so simple idea, let's say you have parametric equation. In order to differentiate, so you will apply a process which called as parametric differentiation. Okay, consider the parametric equation y equal to ft and x equal to gt. So how to find first derivative of the parametric equation? Okay, so we can use this formula. dy dx is equal to dy dt divided with dx dt. Okay, provided that dx dt not equal to 0. In order to find second derivative of your y with respect to x, okay, for the given parametric equation, we can use this formula. Okay, y double prime x can be calculated using d dt of your function y prime x divided by dx dt. Again, provided that dx dt not equal to 0. So how we get this formula? So basically, this formula is come from chain rule formula. Okay, if you can see here, how we obtain this formula for dy dx using parametric equation. Same also to second derivative. The formula also come from chain rule. Okay, as I given here, and then by rearrange, you can get formula for y double prime x of your parametric equation. Okay, let's try example. Parametric equation of a curve is given by, okay, let's say you have two parametric equation, x equal to t minus 3 over t and y equal to t squared plus 4 over t. Okay, first you ask to find dy dx in terms of t. Okay, so we will use this formula. Before we can find dy dx, you must to find y prime t and x prime t first. Okay, therefore we need to differentiate x and y with respect to t. Okay, if you differentiate x, your x here with respect to t, so you can use, you can simplify this, and then it will give you 3 over t squared. And in order to find y prime t, you differentiate your y with respect to t, then you will get this solution. Okay. Therefore, to find dy dx using parametric differentiation, we use these two information here. Okay. So y prime t dy with x prime t. Therefore, you substitute back what you have here and what you have here into this, and then you simplify. So this is your dy dx for parametric equation. Okay, second problem, you asked to find y in terms of x and hence find dy dx. Okay, this time dy dx should be in terms of x. So how to solve this? First, from x equal to t minus 3 over t, you must rearrange to get your t in terms of x. Okay, so that you obtain this. And then you substitute t value in terms of x into your y, your parametric equation of y. Okay, so previously y equal to t squared plus 4 over t. So now we substitute t with this new equation here. Okay, so you will have this. And then you expand this and simplify this equation for numerator and also denominator part. Okay. And then after that you simplify. Okay, this is just a simple mathematics here. Then it gives you y equal to 13 minus 8x plus 4x squared over 3 multiplied with 1 minus x. Okay, now you can differentiate y with respect to x in terms of x. Okay, so this time you need to apply quotient rule formula. Okay, why quotient rule? Because you have rational function here, fx over gx here. Okay, so recall back your knowledge on quotient rule. So if you apply quotient rule, at the end you should get y prime x equal to this solution here. Okay, so please be careful when you apply quotient rule, because sometimes you will make a mistake here. Okay. To double check your solution, you can also compare your result in second problem with first problem by substituting the first equation into result in 1. Okay, now let's test your understanding. Okay, this is from final exam 18-19 semester 2. So you are given parametric equation x equal to t plus 1 over t minus 1 and y equal to 3t minus 1 over t plus 1. Okay, so now you ask to find your dy dx in terms of t, and then you ask to find dy dx in terms of x. Okay, basically this problem is similar with the previous slide. So I give you 3 minutes to figure out your solution, and I also guide you here, okay, in order to give you the idea how to solve this problem step by step. So let's start by find dy dx first, okay, in terms of t. Okay, so now let's look how to solve a second problem. So in this case, you ask to find dy dx in term of x. Okay, so as I mentioned previously, first you must to have your x defined given by this, and then you must to rearrange to get your t in term of x, and then you substitute t into your y before you can differentiate your y. So for this part, I prepare video here, so let's look at this video.
Okay, from previous slide, you already find x prime t, y prime t, and also dy dx in terms of t. Okay, now in example 2, you ask to find dy dx in terms of x. Okay, therefore first step, you already have x, then you must to get what is your t. So from here, if you rearrange, you get t equal to 1 plus x over x plus 1. Okay, so in order to get your dy dx, you must to substitute your t in your y, so that your y in terms of x. Okay, so now this is your y. Okay, now we substitute t in terms of x. So we have here 3. So t is 1 plus x over x minus 1 over 1 plus x over x minus 1 plus 1. This is your t. Okay, now we simplify this. Okay, so if I multiply x minus 1 to this part and also x minus 1 for this part, now I will have 3 plus 3x. Okay, and then I have here is negative x plus 1. Okay, I multiply this with x minus 1, and then over x minus 1, and then I divide here with, so for this one, and also multiply with x minus 1 here, so I should have 1 plus x, okay, plus x minus 1 over x minus 1. Okay, so these two will cancel off. Okay, because if you rearrange this fraction, you can cancel off these two. Now we simplify this, you will have y equal to 2x plus 4 over, you have here is 2x. Okay, so therefore it will give you y equal to 1 plus 2 over x. And then from here you can find your y prime x. Okay, from here you can get your y prime x.
Okay, so after you get your y, then you can find the derivative of y by differentiate your y with respect to x. Then you should get negative 2 over x squared. Okay, let's look at this example. So let's x equal to a cos cube theta and y equal to a sin cube theta. Then you ask to find dy dx when theta equal to pi over 3 radian. Okay, so in this case, you must to get a value. So similar with the previous slide, first you must to differentiate both parametric equation here, but this time in term of theta. Okay, so you must to differentiate with respect to theta. Okay, so for y prime theta, you should get this. Okay, and then for x prime theta, you should get this. Okay, because you differentiate cos cube theta multiply with a, so you should get negative 3a cos square theta sin theta. Okay, so in order to find dy dx, so by using parametric differentiation for first derivative, So we apply this formula, y prime x equal to y prime theta over x prime theta. So you substitute your information here to this part, okay? And then you simplify. So finally you get y prime x equal to negative tan theta. Okay, so after that you plug in theta equal to pi over 3 radian into your dy dx. Okay, so you can use your calculator, give the value in 4 decimal place in terms of radian. Okay, so let's look at this example. Same problem, but this time a different parametric equation, but still in terms of theta. So let's say you are given x equal to cos 2 theta and y equal to 2 sin 2 theta. So you ask to find dy dx at theta equal to pi over 6. So how to solve this? Let's look at this video.
Parametric differentiation. So now we have this example. You are given x equal to cos 2 theta, y equal to sin 2 theta. You ask to find dy dx if theta equal to pi over 6. So first step, we must to differentiate both with respect to theta. Okay. So x prime theta equal to differentiate cos. So give you negative sin 2 theta. And then differentiate this. So you have 2. And then differentiate y with respect to theta. So differentiate sine positive cos 2 theta. And then multiply with 2 here. Okay. So now by using parametric differentiation formula, dy dx equal to y prime theta over x prime theta. Okay, so what we have here? So we have 2 cos 2 theta over negative 2 sin 2 theta. Okay, very straightforward. So what you have here? Okay, so this one you cancel off. So cos over sine will give you cotangent theta. Okay, so you will have minus cotangent to theta. Okay, so this is your dy dx. Okay, but now you are given the value of your theta. Okay, therefore at theta equal to pi over 6, so what we have here, y prime x equal to negative cotangent to pi over 6. Okay, which give you negative cotangent pi over 3. Okay, so this is actually negative cos pi over 3 over sine pi over 3. You can use your calculator, find the value in radian, or if you remember the triangle, okay, triangle formula. So we have here pi over 3, okay, we have here pi over 2, and then we have 90 degree here. So you have 2 here, you have 1 here, and then you have square root 3. Okay, so if you want to find cos, so cos pi over 3 is cos. Cos mean kalau saya hantu. Okay, it's an adjacent over hypotenuse. Okay, so cos pi over 3 is equal to adjacent over hypotenuse, which is half, and then sine pi over 3. So sine pi over 3 is opposite over hypotenuse. So you have 3 over. So you can substitute here. So means that you have here is a negative 1 over 2 divided with square root 3 over 2. Okay, so if you simplify here, so from here you will get negative 1 over square root 3. So this is your solution, or you can convert into radian. Okay, thank you.
Okay, so I think that's all for parametric differentiation. So here I give several selected exercises from tutorial. So please try to test your understanding. If you face any difficulties, do not hesitate to ask your lecturer. Okay, so it's good to do a lot of exercises so that you can know how much you understand on this topic. Okay, so that's all from me. Thank you.